Thank you very much. I'm very pleased to be here with many of colleagues who have experience in the area of automation, robotics, not only from the industrial side, but also I see that there are people representing universities. And actually, I'm both. I'm a professor of computer engineering, but I also am an entrepreneur. So let me begin by actually commenting about our theme. Our theme is transforming manpower to machine power. And we have seen this for a long, long time. The first attempt was over 100 years ago when we transformed raw energy power into machine power using the steam engine. It was raw mechanical power. After that, we saw the introduction of electrical power, of course. And then we moved through data, using knowledge. And as Charlie mentioned too, then came the area of intelligence, artificial intelligence, and things like reinforcement learning that he talked about. But I believe that, like he also mentioned, we are in a perfect storm. It's a combination of several technologies that will have a great impact, and I believe that's going to be very important. In addition to robotics that he talked about at length, we have really many other technologies. Talk about wireless communications for the industrial systems. We're talking about automation, just the next wave of automation. We're talking about a new wave of sensors. He also mentioned about few sensors that it's available, for instance, in our smartphones. But sensor systems really reaching all over the globe. You need to collect data from the sensors, send it to the cloud again, and the cloud will enable really a lot of interesting things to happen. For instance, just think of it, what could happen if you upload all the data collected in just your car, for instance. It's one example. Your car generates lots of data. It's huge data, big data. If you upload it to the cloud, that will enable smart operations. And that's the next way that I believe, smart operations, a distributed set of applications. The distribution means here autonomous, cooperation, synchronization, just all of these systems working together. Distributed systems has been around for a long, long, long time, but in my opinion, we're seeing a new type of distributed systems, which is at the end applications. Before, people talked about distributed systems, distributed languages, distributed blah, blah, blah. But now we're talking about distributed end applications. And this is something that Charlie mentioned too, which is very important. What I mean is that it's not important, for instance, that you just have distributed things here and there. You distribute the end applications, the specific applications. We're at that stage that we can actually have it distributed. And that will enable, it's called smart operations. So I welcome you to these two tracks that we have for today, track 1 and track 3, on automation technologies and control of mechatronic systems. And my co-chair Cameron here will want to say a couple of words, and then I'm going to begin with the first talk. This is going to be my talk. So Cameron?
Yeah, sure. I'll just be really quick. So good morning, everybody. Just a quick introduction. So I'm not an academician. I work for SICK. I basically try to sell all these technologies on a regular basis. So I think what I'll kind of tie together with what Juan addresses and Yutku is just kind of a realistic picture of how day to day we try to implement this stuff with companies like Foxconn and Tesla and Boeing and everybody else, as well as kind of my reflections on how my company SICK is involved in Industry 4.0, which is the kind of German government initiative to roboticize industry on top of what we called Industry 2.0, which was, basic mechanization of industry. So it'll be nice to kind of tie those things together, and it's really cool already just to hear what Charlie talks about in gripping and machine vision, and then the parallels we see in semiconductor and automotive manufacturing. So it's crazy what a small world we live in when you kind of bring together these technologies. So with that, I think we'll reintroduce Juan here to give his talk on contextual awareness systems for unstructured environments using with web-based kind of navigation for robots. So here's Juan.
Thank you again. Actually, this is not the title of my talk, but it's related to the Internet of Things. And one of the things that I enjoy in life, very briefly, is travel a lot. And because I travel quite a bit, I learned 4 languages. It's pretty easy to do that. Internet der Dinge in German, Internet de Subject in French, Internet de las Cosas in Español. So the title of my talk is really this one. Context-aware systems for unstructured environments based on WSN, which means wireless sensor networks. I'm a professor at Kettering, and as I mentioned, I'm also an entrepreneur. My company is called Lesoft. Okay, in my opinion, wireless sensor networks is probably the common denominator for collecting data from just about anywhere. That's what it means. And the best way to do that, to disseminate that information is wirelessly, because obviously you cannot imagine just putting wires on these tiny sensors. It was just out of the question. So I'll talk about 2 different environments, what I call structured environments and unstructured environments. And then I will explain what I mean by this and propose a really architecture for platforms. I work a lot with platforms of IoT, which means Internet of Things. So there is a talk actually on the 3rd day that covers precisely Internet of Things. So this, I have 3 slides about that, but it's not intended to be a coverage of Internet of Things in general. But obviously I need to mention something about that because that's the context that I'm talking about. A lot of people like to define things, and this is something that's not a very clear definition because it's so broad. It's mostly an idea that has been around really for a long time, but so a lot of people really say whatever that is going to be huge. It will change everything. So there's a lot of talk about this. But myself and my company actually were doing actual things, So even though I'm a professor, but I stopped doing theoretical research for about 10 years ago, and I'm doing practical things now. So my research and development, if you will, is industry-oriented or product-oriented, no longer theoretical research. So a lot of people saying it will change everything. People like John Chambers down the road from Cisco, he's a huge proponent of this. So whatever that is, people say it's going to be huge. So we'll see that. And also there are some statistics or predictions in terms of how big it will be in terms of the number of connected devices, and also in terms of the investment or the market, if you will. So, for instance, by 2020, some say that it will be an $8.9 trillion industry. So we'll see, as I said. So there's a lot of hype about this. But believe me, beyond the hype, it's happening. It's really happening. Perhaps slowly, but it's definitely happening. This slide is a little bit old, about a year and a half. And as you could see, similar to the slide that Charlie showed us for robotics. But the thing is that there are new developments that is allowing, this is the number of devices to be connected by this technology. It's growing nearly exponentially. So why does it matter? Because this is one of the things that, again, Charlie mentioned. I'm quoting you, Charlie, a lot, and that was a good presentation. We have a perfect storm, and the Internet of Things is part of that storm, basically, that he's talked about. So we're concerned, or we're interested in interconnecting things. And a big question, of course, is what is a thing? And a thing could be very large, could be a car, for instance, could be extremely tiny. People are talking about sensors, for instance, that fits in your eye and actually have a way of transmit the data that collects from your eye, obviously wirelessly. So it could be extremely tiny or it could be big. could be machine. A robot could be considered one thing. So it depends on how you define a thing. So, but we're talking about really smart objects. We're going to capture something about that object and make it smart. What that means is basically with connectivity and able to have make decisions. In other words, it will have some kind of a processing power to it. Again, this is an early picture. They're only 2 years old, but the thing is that the Internet of Things will actually involve many industries, many areas, because it's broad. It will actually permeate the world, as some people say. It will be everywhere, which also means that you cannot just make a smart object for everything. Like, again, Charlie mentioned a hand for everything. I agree with that observation. You need to pick an application, and in that application, you apply these concepts and make it work. Okay. Here you see many applications in the home, transport system, community, national infrastructure, I mean, healthcare. So there are many what it's called verticals today. It's called an IoT verticals. It's one of these industries that you pick, and then you need to obviously work in that vertical, in that specific application. Again, this is a more recent picture about the kind of devices that can be connected to the internet, and as you could see here, quite a variety of them. But actually, it's an introduction to what I'm going to say next, which is structured environment versus unstructured environment. Again, this is the last picture on the IoT. Much newer data. Again, as you could see, the range of sensors here, and actually the size of it, and how they start to proliferate. So, again, IoT is huge, very wide, and these are just some of the technologies behind it. And this is, granted, it's a little bit on my side of things, not so much robotics or manufacturing, but this is strictly on the IoT portion. Definitely sensors, all kinds of sensors, connected with RF, radio frequencies, all sorts of frequencies. In fact, there's that area. It's actually a big area of research. I don't know if you have followed the latest news about that. For instance, the FCC is making what's called the RF channels available for internet communications. That's huge. So, low-cost computers. Computers are coming down in cost. Everybody knows that. Instrumentation, smartphones. Some areas that I've been working on lately, as I mentioned, is SDR, software-defined radios. And that will allow us to actually use pretty much any frequency band in the spectrum. And that's going to be huge, because what's going to happen is that everybody's talking about big data in the cloud. You need to send data to the cloud, and that's done wirelessly. So that's going to be a big problem in the future. And in my opinion, SDN with software-defined networking and software-defined radios will be big components in solving that particular problem. Okay, back to the main idea of the talk. So up to now, it's really an introduction. In these IoT environments or applications, I see two main types of environments. One which I call structured, and one that I call unstructured. And it's fairly easy to see the difference. Structure means homes, for instance, building, factories, hospitals, automobile, which means that you know the type of devices that's out there, you know the type of data that generate, the frequency, so you know a lot about those devices. And therefore, it's easy to automate things with those devices, or at least easier than the rest of the world, if you will. Because IoT, remember, it's Internet of everything, right? So unstructured would be anything else. So I've been, I have been working on a project which is unstructured, so that led me to think about these particular issues. and also to choose what is called a IoT platform for these unstructured systems. So the characteristics of these two things are quite different. They're not, obviously they're not the same. And this has implications on the way they're designed, on the way you analyze it, on the performance, on the cost, on the deployment, on just about everything, obviously. This is a short overview of WSN, wireless sensor networks. Has been around for a long time, at least the concept. The implementation is a little bit behind, okay, because there are some big problems. And believe me, most of the problems is because of the wireless nature of this, wireless communications. Because just to give you an example, for instance, you know that Wi-Fi really talks about Wi-Fi, and even there are other solutions. The maximum range is only about 20 meters, 30 meters, maximum 100 meters if you're outdoors. And that's not enough, really, okay? There is not much you can do with 20 meter, 30 meter, 50 meter connectivity in terms of the new applications coming up, which is hardly dynamics. They're mobile devices. A car, for instance, moving 100 miles per hour or something. In German, it's even more. So what you do is then, this is a different type of wireless sensor networks and environment where, as you could see, you have sensor nodes, could be very tiny. This could be deployed anywhere in the world, not necessarily in areas where there is wireless connectivity or Wi-Fi. So you organize them in what is called in hierarchical fashion. And I agree with this particular structure. It's a hierarchy. At the lowest end of the hierarchy, you have the actual sensor nodes, tiny nodes, very low cost, obviously with some type of wireless connectivity. And then they send the data to what is called a cluster head node. The head node collects the data from the actual nodes. It will compress it, organize it, and sends the data to what is called a base station. The base station is assumed to have internet connectivity. All the other ones do not, okay? And then the head node will send the data most likely through other head nodes, you know. That's a hierarchy. And then eventually the data will make it to the base station send it to the cloud, you know. So it's a typical arrangement. Lots of work has been done in this area. In terms of practical implementation, we're a little bit behind. In fact, I'm participating in a project where we do this for very remote areas, extremely remote areas. And we're almost finished with the project, so we're able to collect, we will be able to collect data. The project's still 6 months away from being finished, but we'll collect area from these circles, could be around 10, 15 miles each. So this whole area could cover easily 50 miles, 30 miles, something like that. And this is an area where there is no internet connectivity whatsoever, and except for the base station, obviously, you know. So this is a wireless sensor network. Going back to features of structured environments, well known. I have many colleagues that work in this area. I'll just present two results. This is not my own work. This is from IEEE Transactions and Industrial Informatics, where I'm an associate editor. But the thing that I'm talking about here is that, as you could see, it's well structured. And you have things like discovery. You have the communication using all kinds of wireless technology. You discover services, and then you find out about these services all automatically and make use of these services. This is how the automation is going to be placed. So we're automating even how to make automatic systems. So you have composition. We're talking about what is called a service-oriented architecture here for this one. That's what SOA means. So you see things like service discovery, service composition, and context aware, which is very important. The context basically means, and this is something related to what Charlie said, you cannot solve all of the problems in one shot. You need to find the context. And within that context, you solve the problem. Okay, that's the idea. So this whole area of context aware research is very, very large lately, and that's what it means. So there are some features. This particular previous slide is for factory automation, very structured environment. People have been working on this for a long, long time. and these are the main features. Do you have a specific modules, control system, or devices, for instance? A robot is a very specific device. A control system, specific device. A PLC, another specific device. So it's well known. And this is what you have. This is another paper that analyzed in depth in the area of factory automation. Again, this is IEEE Symposium on Industrial Systems. There's some colleagues from Germany who did that. Again, they're trying to automate, for instance, how you configure your communication systems down on the factory floor, given the fact that you have several choices. So on the right side, you have basically the model. On the left side, you have the implementation. And you have things that you decide. For instance, you decide on what kind of protocol are you going to use based on the devices that you have and whether or not they're supported. So all of this is automated. So if you compare then these two environments, the structured and unstructured, in several categories that I don't have time to define in great detail, but I mentioned a little bit of this in my prior analysis. So you're talking about the type of sensors. You're talking about whether or not you need network access to what kind of networks do you have, basically. The kind of operations that you do, for instance, machining operation, stuff like that. The processing entity that you need. SOA, as I mentioned, is whether or not service-oriented architecture would be appropriate. There's another category here, it's very important, called web services. It's a new technology where it's going to enable automation using the internet, the web base. And then whether or not the platform is fixed, I'm talking about the IoT platform here, or very flexible. So as you could see, the structure, the answer is kind of well known, and the unstructured, what I mean is, in the sensors, for instance, you have a wide variety of sensors. You cannot assume that you have just certain types. In terms of access networks, again, you have several. You have even Bluetooth communication. You have all kinds of wireless technologies, wireless protocols, not just, I guess, Wi-Fi, that's what I'm telling you. In addition to Wi-Fi, currently, there are some solutions out there that are using about 4 or 5 other wireless protocols in addition to Wi-Fi. The processing entity in the structured environment tend to be device-oriented, and in unstructured, it needs to be device plus event-based. Service-oriented architectures, that's a good thing to have. Likewise, web services. Platform needs to be very flexible. So the conclusion is that non-structured environments are much more complex because, I mean, the environment itself is complex. So therefore, the platform is the hardware, the software, and the logistics to develop these things. Okay, that's what the platform is. So the platform also needs to be complex by virtue of the system being complex. Flexible, meaning that you need to deal with all types of environments. Context aware, again, this is very important. You cannot solve the problems generically. You need to define the context and then solve the problem within that context. And then mobility. As I said, I'm working on another project in the car industry where we're trying to upload the data generated by the car in one day, which is huge. It ranges between 10 and 30 gigabytes per day uploaded to the cloud. All of the data collected by the sensors, as you probably know, there are networks inside the car, and they use CAN bus, the CAN bus. And there's not just one CAN bus, there are 5 or 6 or 7 buses, you know. Collect all of the data, send it to the cloud. So, but the car is moving, so that's a big problem. The car is moving pretty fast. So basically you have a dynamic network of mobile users with unpredictable and unstable behaviors. That's the challenge that my colleagues and people in my area are working on. So I developed these features for a platform for unstructured environments, which I generalize a similar figure that has been using IoT for a while. But I included several components here. The most obvious components are sensing on the left. This is where the data is gathered by the sensors. Could be thousands of sensors. The transport portion, which is the networks, mostly wireless, up to the point where you need to put it to the internet, and then that's just the internet to the cloud. Store, either locally or on the cloud. So typically you have this, which is fairly obvious, and also the analytics. Charlie also mentioned that if you have lots of data there, you could make all type of analysis and optimize things, improve things, make operations much more smarter. I think that's the final end game, okay, to enable smart operations in whatever industry you are. So this, and then as you could see, I added context here. So you do analytics based on a context, which is different than if you try to do it without a context, which is a totally different thing, of course. You need to handle events. So you have an event type of module here. And you can not only do analytics, of course, which is basically data processing to try to find patterns and improve things, but you do all sorts of things. You could just basically monitor. You could do controls, which is very important. You could do value extraction. That's very important because value is related to, I guess, your profits, you know. And what do you do with all of that after you're done? Well, you either consume it yourself or you share it or sell it, you know. So a platform that will allow you to do all of these things would be a terrific platform. And that's what I'm working on. In fact, my company is actually working on that. We have one that does most of this. And we're working on completing the whole thing. Let me give you a few examples of what I'm talking about. This project I just completed, this is actually a university project. Again, I mentioned that I stopped doing completely theoretical research and doing more applied research. I wanted to design a SCADA system. I think we have a talk from SCADA here today or tomorrow. Supervisory Control and Data Acquisition System, right? Has been around for a long, long time. But SCADA is being redesigned, redeployed lately because of new technologies, particularly IoT. And I wanted to work in water treatment. Water treatment is huge, though. And so what I decided to do is to work on what it's called a test bed. And what you see here is a test bed. It's a complete water treatment process. It's not a plant, it's a process. You have 3-stage filters here. We use the microfiltration approach. We have 2 chemical, a base and the acid solutions here. And we want to monitor the quality of the water. Water is very important. So we have sensors that monitor the quality of the water. We monitor pH, ORP, DO, and water flow. So this is the monitor portion. This is the array portion. It's kind of small, but it allows you to do stuff. And then we do automatic control of pH. And then we have developed mobile apps for this. So you could actually monitor this with you. Whatever you do in a typical SCADA system, you could do it in mobile apps today. And this project was extremely successful. Here you have a picture of the mobile app. Oops. Here you have, it's not shown, but you have manual control and automatic control. You have monitor version, you have control version. We have even an app to do teaching, to teach operators on this process. Okay? And the operators, while they're learning, they will be able to actually see the actual sensors. We don't enable control because it could be dangerous. Control is a very, very dangerous thing. So it's only monitoring for the teaching app. But for the process app, you can do controls, either manual control or automatic control. You have an example of the monitoring app here. It's monitoring the levels. This is another example, smart home, but we went beyond the typical controlling the lights. We also control security, as you could see, and even environmental sensors like carbon monoxide and stuff like that. So we could do a lot of stuff at the home. This is the first floor, I believe. Yeah, the first floor. And you show, again, you have controls. As you could see here, you could determine the thermostat with a slider, and then you will control the heating or air conditioning, second floor. So this will be a smart home. The smart operations that you can do here is obviously your savings in terms of heating and lighting and CO levels. The system is quite sophisticated. Here it detects a communication fault on the network. This is still another one, smart irrigation system, where the sensors are ground humidity, line pressure, and flow rate, and the actuator solenoid valve. And we use it in the weather channel to predict, not predict because the weather channel does the prediction, but we read the prediction in addition to measuring the ground humidity, and based on that we decide when the lawn should be watered. Again, sensor by zones. We get the data from the weather data. It's a good example when I'm talking about web services. That's a service out there. It's available to anyone. If you know how to use it, it's pretty easy to use. Then you get all of those readily available. Systems from, other pictures from the smart irrigation system, GUI, graphical user interface. So this is in the context of this effort called Industry 4.0, spearheaded from Germany. I believe it's a picture from 2013 in the inauguration of this particular one. Even Mr. Putin is interested in the...
Must be 13 years.
Yeah, right. So that is the end of my talk. At this point, I'd like to answer any questions that you might have.
One question I have is concerning unstructured environment. You mentioned this, and you consider the industry segment automation as a structured environment.
Yes.
So far, our experiences as we are doing, we are producing sensors, also actors. We are controlling via wireless operations, and we are collecting data that right now the structure for sensors in the industry is not really organized well, because communicating with a small sensor is not the same than communicating with a 6 sensor. How is there anything from your point of view you're going to develop to connect these sensors in the industrial environment together?
No, that's a very good question. By the way, my classification is not black and white, obviously. It's extremely difficult to do that. What you're asking, or the point that you're bringing, is that even in factory automation of industry, you may have some unstructured environments, and I agree with that. So my classification is not black and white. It's mostly, for the most part, there are exceptions to the rule, obviously. Okay? Yeah.
Similar question. If you look at what the military wants to do, it's an unstructured environment, yet they're in control. They can control the platform and standards. I was just curious if you had any work with them, or is there anything being developed there that could flow over to the unstructured environment generally?
That's a very good point, Charlie. No, I actually don't work with the military. I guess they don't trust me. No, just kidding. But I do know some colleagues, and I read some papers related to that. And yes, the military is very unstructured. As a matter of fact, wireless sensor networking, a big push or a big input from that comes from the military, really. Not all of it, of course, but it comes from the military. Yeah. Yes.
It's a comment actually rather than a question. So it's not actually going to structurize unstructured environment. It's how to put some system to utilize or to, get data in a way
That's
that
right,
can
that's
be,
right.
benefited from unstructured environment.
Exactly.
Yeah.
No, we leave the environment by itself. I'm not talking here to structurize it. No. All I meant, or what I mean, is that the environment by itself, what I call is unstructured, right? And I'm trying to deal with those systems, meaning how do you collect data, number one, and how you transport the data. The transporting is very, very difficult in some cases. I'm talking about mobile, far away where there is no Wi-Fi, so you do it with reliability, very reliably, right? So that's a challenge, and also security. In the project I'm working on, for instance, as I said, I'm working with two projects. One is the unstructured sensors in a very wide area networks to collect the data, 30 kilometers, 50 kilometers wide. And the other one is the car business, right? So if you want to upload all the data in your car to the cloud, for instance, that data is sensitive, by the way, in case you didn't know. I mean, manufacturers would not like other people to know what's on the canvas, for instance, with IDs. They don't. So security is extremely important. You cannot just send it there and forget it. That's a no-no. Okay.
It's the question of security, as you have mentioned your infrastructure of communication. And our experience is that we are already collecting data, and our customers, like for instance in the automotive industry, Mercedes-Benz, they don't want to share that data and don't want to put them in the cloud.
Exactly.
So, and all this makes it necessary to limit this to specific stages, to say data can be used until this and that and that. Is this also something you're considering in your project?
Yes. More specifically, in the case of the automobile, right? One thing that we're working on, in fact, is to upload all of the data, but decouple it from the IDs, CAN IDs. Because in CAN, I don't know if you know about CAN in detail in general, but they use a very important concept called CAN ID. The CAN ID serves two purposes. Number one is to have access to the bus on a priority basis. It's a very interesting protocol. But in addition to that, it actually identifies the data. Okay, and the data organization is tied into the CAN ID. So CAN ID is a protected type of a mechanism. You don't want the CAN ID out there. In fact, manufacturers today, they don't like to reveal the CAN IDs for the system unless it's all related to emissions. Then you can have it. But the rest of the design is totally hidden. So we are experimenting with transmitting the data where we don't send the CAN IDs. So then that would be a very, very good thing to have in terms of security. Yeah.
Another question, in the Internet of Things, especially unstructured environments, many sensors, there's the issue of the power, the energy necessary for those sensors.
I didn't mention that. Absolutely, yeah.
Yeah, so I was just curious, and you're looking at these unstructured, I'm not an expert here at all, but the only sensor I'm aware of that doesn't require power is the RFID passive tag, which gets energized by the reader. Yeah. Do you see that playing in a lot of these applications?
Oh, you bet. Charlie, that's an excellent question. In fact, energy awareness is one of the most important considerations in wireless sensor networks from day one. Very important. It comes from the military, you guys, that you're talking about. These nodes, they're designed to last years with just one battery. Okay, there are techniques to do that. In fact, I know of an industrial solution right now. People who know in the process automation industry probably recognize that Emerson has a network of wireless sensors for process automation that they use IEEE 15.4, not Wi-Fi, which is a different standard. But their nodes last for 5 years with one battery. That's a good solution. It has to last at least 1 year. But yeah, very important consideration, absolutely. And there are solutions to do that, yeah. And that, we're using that in my project too, by the way. any other question. So with that, I think, thank you very much. And